Hello, so today we're looking at Demoivre's theorem in terms of using trigonometric values. So we know from Demoivre's theorem that if you raise a complex number by a certain number n, then you distribute that through your complex number to get a few calculations. So let's have a look at this question here where we got, consider cis 2 theta expresses real and imaginary parts to these double angle identities. So when we're looking at this cis 2 theta, we can rewrite this as cis theta squared. And that's from what we know about Demoivre's theorem. So because we've got cis theta squared here, we can rewrite this as cos squared theta plus I sine squared theta. And that allows us to actually start looking at expanding it out using our perfect square rules. So if we expand this out, what we get here is we get cos 2 theta plus 2 times sine theta cos theta plus I sine square theta. Now because we're looking for real and imaginary parts, we know real is going to be in terms of cosine, and imaginary is going to be in terms of I sine, remembering our unit circle and our complex number build. But we can actually work with this a little bit further, because right now I've only got one real value. I've got my I there. Okay, so what we can fix up is this side of the working out, because we've got that as sine squared, which is the same thing as having everything squared here, which then becomes I squared sine theta squared. And we know that I squared gives you a negative value. So we can rewrite this over here as cos squared theta plus 2 sine theta cos theta I minus sine squared theta. And now we're in a position to be able to work with and find our first double identity angle. Now, because we want real and imaginary, let's look at the real part first. So the real part is going to be in terms of functions that don't have the imaginary component with it. So in this case, we'll have cosine squared theta minus I sine squared theta. This in itself is a double identity angle, but as I said before, the real parts have got to be along your x-axis, and your x-axis we know cosine is that calculation. So somehow we have to rearrange I sine squared theta into a cosine, and we know we have an identity for that, and that identity comes all the way back from the first identity you learnt way back in, I don't know, year 8 or year 9, okay, maybe year 10. We need to rearrange this, so therefore sine squared theta is now equal to 1 minus cos squared theta, and now I can take this knowledge and bring it across. So we now get cosine squared theta minus 1 minus cos squared theta, and it's just a matter of now expanding out. So cos squared theta minus 1 plus cos squared theta is now equal to 2 lots of cos squared theta minus 1. And there is our real part of this complex number up there, cis 2 theta. The imaginary part, well, we've already got that. It's just here. And it's already in our form of a double angle in terms of sine. Okay, so therefore, if we're only looking for real, then I would stop here. Okay? And then my sine one will be 2 sine theta cos theta. And then this here would be your imaginary. So when we're looking at these types of calculations, it's important that we identify our identities that we used before to help us solve what we're looking for. Good luck with your questions, and I'll see you next time.